Photography, the art of capturing a moment and keeping it that way forever. Behind every art, however, is a science, and in particular, chemistry. I am Dr. Patrick Westervelt, and today we will be taking that art, that science, that beauty, and explaining it to you. Welcome, viewers, to the most amazing photography-related project on this side of town, the Gibbs side. In this project, we will investigate each aspect of the art known as photography. The history of photography will be explained, and it will lead way to the way that the camera works. The steps of developing pictures will follow, and a report of the lab used to develop my actual pictures and the film development. The science behind photography will, in these, be accentuated through the whole project. The project will conclude with my finished pictures, a formal conclusion, a glossary, and list of references. Beginning with the history of photography, the project formally begins now. Alhazen, pardon the pronunciation, invented what is considered the first camera around the year 1000 AD. At this point in time, however, the camera was only used for things such as drawing and observing. In 1827, Joseph Niesmohr Niepce took what is considered the first photograph, but his photos were very different. They required hours of exposure to sunlight, and after revealing their picture, it would fade over time. Louis Daguerre was experimenting at a similar time, and eventually developed a way to make photographs that did not fade over time and had a relatively low exposure period. Daguerre and Niepce eventually collaborated, and even though it was only finalized after Niepce's death, the daguerreotype was eventually created, which is the template for all forms of photography. The daguerreotype allowed images to stay on the film by having them washed in silver chloride. Daguerre and Niepce's son sold the rights to the daguerreotype to the government, and within years the process became extremely well known. In the years that followed, several innovations were made. In 1841, Henry Fox Talbot developed the first negatives. In 1851, Frederick Scoff Archer invented the wet plate negative. In 1889, George Eastman invented the flexible film roll. Color photographs, Kodachrome, were invented around the 1930s and became widely available and used in the 1940s. In 1963, Polaroid film was developed, allowing pictures to be taken instantaneously. 1984, move over George Orwell, birthed the first digital camera and developed by Canon. Today, further developments are being made in all types of cameras and will continue into the future. Now, most cameras are made of very similar parts. Cameras have three primary parts: the lens, the film, and the mechanical part of the camera itself. These three parts equate to the viewing portion, the chemical recording portion, and the, mechanical portion. The lens of a camera is a piece of glass that detects light. The light from other objects bounces off of them into the lens, where it is temporarily stored. It is able to do this because light moves from the air into the glass, where it travels more slowly. The light is redirected and pointed at the same place, where the image begins to take form. After the image is recorded in light, it's time to make a chemical recording of this picture, otherwise known as the film. The film is mostly made of gelatin and plastic. Films have many light-sensitive grains on them that begin undergoing chemical reactions upon their exposure to light. In development, the grains are exposed to other chemicals, which begin causing a new reaction to take place, causing the picture to develop. This development forms a negative, where darker areas are lighter and lighter areas are darker. When the pictures are finalized, it is converted into a positive, which is just an average picture. Light areas are light, and dark areas are dark. We will get to this process shortly. The camera, obviously, only handles part of the process of pictures. The other obvious factor in the development of pictures is the, development. Besides the initial wash, soaking the pictures, there are only a few primary steps. In exposure, light-sensitive grains are exposed to light, causing the chemical reaction to begin to take place. Next is the main developmental process, in which a lot happens. The developer has to be diluted with water and poured into a tank. After being filled, the tank has to be shaken every minute for 10 seconds, and after an appropriate amount of time has passed, the developer must be poured out of the container. Acetic acid must then be used as a stop bath solution, shaken several times into the container. The fixing solution is then poured inside to help fix the image into place. It, similarly, is shaken for 10 seconds every minute, for about 5 to 10 minutes. At this point, the image is fixed into place, and can be exposed to light. The container is emptied and filled with water once more, where the film will be shaken inside to get rid of the fixing solution and any leftover chemicals. Next, a wetting agent is put inside the container with some water, and is kept with the film for 30 seconds. The film is removed from the container, and now a negative left to hang for several hours. Now that the negative is made, however, it must be developed. The enlarger sends the image of the negative onto a large sheet of photographic paper, a base. It controls the amounts of things and light and contrast. The photographic printing paper is then used through a photographic developer. It prints the paper, rinses it with stop bath, fixes the image permanently, and washes all the remaining miscellaneous chemicals out of it. The picture is dried and is now fully developed. Huzzah! Important terms and variables in this process include the following: agitation, which is when the dish/tray is rocked, and when done incorrectly, the picture will develop incorrectly, with streaking or straining. The temperature is also very important, as heat can cause parts of the film to melt and reactions to happen too quickly. Likewise, environments too cold will likely lead to chemical reactions being slowed, or not happening at all. The focus of this project is on chemistry, so obviously photography has quite a bit of that going on in it. The various parts of film go through a whole bunch of chemical reactions during the process of development, which has already been described here. Here, we get to see the nitty-gritty of each of these steps, and how things change. For example, when silver bromide gets activated with light, it turns from an ion to a metal, which is what helps create the image. The chemical equation is just from ion to metal, AgBr to AgBr. The stop bath solution is the next thing to be added. The chemical equation is 2AgBr to 2Ag plus Br2. After this, the mixture is watched, so that part of it returns to how it once was. Water is obviously added, which causes the following reaction to take place: H2C2H3O2 to C2H3O plus H2O. After this, the fixer solution is put in, causing the final reaction to take place: 2AgBr NH4 to S2O3 to 2NH4Br plus Ag2S2O3. The film is finally washed to get rid of any miscellaneous chemicals, ridding it of any compounds besides the final one.